Transformation of trigonometric functions. Question 5. Sketch y equals to 3 sine of 2 times x minus 30 degrees minus 1 within a time frame of 0 to 360 degrees. So that's the domain for x value. Now you've seen in first few questions how my approach is to go from backwards, right? How I approach is first I draw a curve and then I plug in the values. That is kind of a reverse approach, and I've seen it to be most effective to sketch trigonometric functions, right? But here this is a very complicated question. My approach may or may not work, so it's a test for that also. I will also show you how to really sketch or graph the function exactly on a graph paper. Without using the graph paper, of course, but give you a method of doing so. And then you can make a decision which approach to follow when. Sometimes when you are asked to graph, you need to graph it, right? Showing all critical points. But as I said, sketch means showing limited points which are critical for your equation, correct? Now, sketch 3 sine this within that period, right? So that means we're kind of sketching one wave. When we say x is between 0 to 360 degrees, then we are actually sketching one wave. That is kind of important to understand. The function may have two waves in 360, that's a different story altogether. But as far as x value is concerned, it is between 0 to 360. So sine x, which is our parent function, will be like one wave, correct? So to sketch this, what I'll do is, I'll just make couple of wave like this. So we'll start from a sine wave, and let's say this is our wave, right? So I just sketched a sine wave here. Now, after sketching a sine wave, I'll fill it in. So I know that is my function. Now, fill it in like how? We'll always start with axis of symmetry, which is minus 1. So we'll just draw a dotted line showing axis of symmetry of minus 1. So which will be from here, correct? So we say, well, this is my axis of symmetry for this wave, right? So this is at minus 1. So mind it, I'm doing some rough work on the side. So I'm writing this as, this is my, I'll write here, y equals to minus 1, y equals to minus 1, and that is my axis of symmetry, right? You understand that part, correct? Now, since amplitude is 3, the maximum should be how much? Since amplitude is 3, the maximum should be 3 more than this, right? So this point should be at 3 more than this. That means on the y-axis, 1 plus 3, this should be at 4. And minimum should be where? We'll say, well, minimum should be 3 less than this, right? So 1 minus 3. 1 minus 3 will give me y value of minus 2. So that should be aligned with minus 2 on the y-axis. So you got already all these points. Now the important thing is the time period. Now how do you find the time period for this function? So we know time period is what? Time period t is equals to 360 divided by the number of waves, which is 2 here. So we have 360 degrees divided by 2, and that leads to 180 degrees. So my time period is 180 degrees. So actually my sketching is in two parts always, because I do phase shift later on. It's kind of tricky to do phase shift and things together. It's kind of confusing too. So what I do is I make two waves. First wave is, I've already drawn one, which is there right before you, and time period is 180. That means if I start this place at, see, I'm writing here, it's just outside the sketch portion. Let's say if I start here at 0, then one wave from here to here should actually end after one time period of 180 degrees. So that should be 180 degrees for me. That is how I see it. So I've done 3 sine 2 and minus 1, and I'm left with this minus 30, which is the phase shift. Now minus 30 indicates me that I have to move my wave 30 units to the right. So now see my calculations. So if this is 0 to 180, that means this part is 90, correct? So on my x-axis, this is 90. So I'm writing 90 here. Since I have to move to 30 units to the right, this should be divided into 3 equal portions, each of 30, right? So let me do that. So 1, 2, and 3. Well, it doesn't look like right, but anyway. So what we will do is, I'll make with the blue pen because that is very far away. And I want to do as accurately as I can. Okay, so this. So these blue marks are 30 each. So it is 30, 60, 90. And then again 30 each, 30, 60, 90. And then again 30 each, 30, 60, 90, right? So those are my each division of 30 degrees. So I've got my horizontal scale. Do you see the beauty of horizontal scale? Your horizontal scale should always be related to phase shift. If this was 45, I would have just divided into 2 portions, not 3. That's the issue, right? Understanding the concept and then building on it is the main issue here. I'm just teaching you very, very basics and the best possible ways of doing things. Now let us transform this graph which we have. That is, we have to shift every point 30 units to right. That is the horizontal translation. So let's do that part. So 30 units to right means this point will move from here to here. Do you see that? And that peak will move 30 units right. So let me just now draw my vertical lines to help me or to guide me sketching. Is that okay? It is a very fast process. The only thing is I'm trying to explain you, so I'm rather going slow. Otherwise, in one shot, I would have drawn the final graph. Now, so these are my 30 degrees partitions, right? See the beauty. I'm not using a graph paper, but my graph is going to be as accurate as graphed on a graph paper. Now, so what we have here is the original sine wave with a time period of 180 degrees, but we need to shift 30 degrees to right. So every point moves 30 degrees away. So that point comes here. Do you see that every point moves this and that point comes here? So you see your wave actually gets transformed. Instead of starting from here, you get the wave like this. Do you see that wave? So this is parallel to this. Do you see that? And then move this point here and move this point there, and you get your wave, the peak coming down from there, and then it's coming down like this. So I'll just draw a dotted line here. You're like this, going like this, and then turning from here, and then going up 30 units is shifted this place, right? Kind of like this, and going up. Do you see the wave? So that is my final answer for this question. And what really happens is that the wave starts from 30, right? And ends at 180 plus 30. Do you see that? That is how it is. Now, so what I did in this question was, I did one basic mistake here. This was -1 and I took it 1 unit up. So let me now just make this plus. I didn't really see that part. Okay, so that was a mistake to start with. And now when we are into the mid of it, it's easier to correct the question than to correct the answer, right? So I have that flexibility. So let's get back. So think as if the question was y equals to 3 sine of 2 times x minus 30 degrees plus 1, okay? Because I took y as plus 1 here to start with, okay? So that's the problem which we are solving, not the -1, the originally given to us, okay? Okay, pardon me for that. Now, so we have a wave here at +1, so the whole wave moves upwards. So of course, if this is +1, the wave is moving upwards. So in our scale, we have from here, that was 4, and this is 1, this is -2. So we have 0 somewhere here, correct? So it is 1 unit, 2 unit, 3 unit, 4 unit, correct? And 1 unit, 2 unit. So that is my zeros. Now I'll draw my x-axis. Do you see? I'm drawing my x-axis now. That is my x-axis. And y-axis I had decided earlier. That was my y-axis. So I'll draw y-axis this. Correct? And now I'll label and fit in all my points. So that's my 0, Let me extend it here. How does it matter? So I have a 0 here, right? And these are 30, 60, 90, like that it goes. Do you see that? And this one is 180 for me. And that one where my wave ends is 30 more than 180, right? So it is how much? 210. So this is 210 where is the end point for the wave. And the beginning, which is this point. It's not here, but this is 210, okay? That is 210. Now, so that is how this wave is going to be, correct? So, you see all the peaks and everything has shifted 30 units to the right, and that's how you get your wave. Now, second method to draw this is by transforming the points. I hope you understand this, except for that mistake which I made right in the very beginning. But anyway, just to repeat the process, the thing is draw your wave. Then draw your axis, which was +1. So we draw axis at +1, amplitude of 3, 3 up, 3 down. So we get those points, maximum, minimum points, and then we find the time period. 360 divided by 2, so we know from starting to end, the wave will be 180 degrees, which was from here to here, correct? 180 degrees. Now, shift of 30 means the wave will really end up 30 degrees ahead of it, right of it. So 180 plus 30, 210, and we'll start at 30, not at 0. So the blue line shows us the transformed function. So from here to here, that is our transformed function, y equals to 3 times sine 2x, that is what it is. Now the real method to graph it is something like this. So what you do is you make table of values. Now for a sine function, we'll write x here and we say y equals to sine theta. Correct. In general, for 0, sine theta is 0, right? Then you see these critical points. That means at 90 degrees, sine is 1. At 180 degrees, these are your degrees, correct? See, sine wave goes like that. At 90 degrees, it is 1. At 180 degrees, let me sketch one here for you. Okay, wait. It doesn't matter. So we'll just do it here. Correct? It helps. So that's your general sine function. Correct? So the critical points here are from 0 to 360 degrees. Correct? So 0, 9, at 0 it is 0, and at 90 it is 1. That is your 1. At 180 it is again 0, right? Correct? And this is 270 degrees. So it is 270 degrees is minus 1. That is your minus 1. And then at 360 degrees, we again have a 0. So that is how the sine function fluctuates. Correct? Now the transform function right there is this. We will see how the points get transformed. So the knowledge of transformation helps us to get the accurate points. The x values really get divided by 2 and then you add 30 to them. Correct? So we do, this is my x original value. What happens to them in transformed functions? So we'll write x transformed values will be original function divided by 2. So do x divided by 2 and then add 30 degrees to it. You get x values of these points. For the y values, you need to multiply by 3 and add 1. So y transformed values will be 3 times y value plus 1. So that is what y value will be. Correct? So let's do that part. So when you do 0 divided by 2 is 0 plus 30 will give me 30 degrees. Correct? And the y value will be 0 times 3 is 0 will give me just a value 1. For 90 degrees, half of 90 is 45, and 45 plus 30 gives me 75. The y value of 1 times 3 is 3, 3 plus 1 is 4. 180, half of 180 is 90, 90 plus 30, 120 degrees. 0 times 3 is 0, and then you get again 1. 270, half of 270 is 135. 135 and 30 is 165 degrees. and minus 1. Minus 1 gives me 3 times minus 1 is minus 3. Minus 3 plus 1 is minus 2. So we get minus 2. 360. Half of 360 is 180, and 180 plus 30 is 120 degrees. Correct? And 0 times 3 is 0, plus 1 will give me 1. So these are my transform points, right? So I can write them as xt and yt. Correct? So what happens is, on a graph paper, then you take a grid like this, correct? Now since the phase shift is 30 degrees, your each division should be a multiple of 30, right? So that you could do 30 very easily, right? Otherwise, dividing it is right. If you do 45 as each small division, then making 30 is great approximation, which will not be leading to a good graph. So 30 should be minimum. So on your graph paper, mark 30s, right? And then plot your point. First point will be 31. So you got to do 30, and that is your 1. Do you see that 1? This is your 1. So 30 and 1. Second is 75 and 4. So this point right there, the peak comes, will be at 75. Correct? So which is 45. Earlier the peak was as 45, right? So this is 45. And when you add 30 to it, you get 75. So that point will be 75 as shown. 120 and 1. So then next point at 1 will be at 120. Do you see that? 90 plus 30 will give you 120. That is the next point. And then 165 at minus 2. So this point which you are getting here at minimum, right, will be at 165. Correct? So that is how. And the last point is 121. Oh, sorry, 2. This should be half of this was, 180 plus 30 is 220, not 120. 210. What am I writing? Okay, so let's do it again. 180 plus 30 is 210. So this is 210 degrees. I wrote it wrong. So 210 and 1 is your final point. So once you have these points, connect them with a smooth sinusoidal curve and you get your final function. So that's an ultimate graph. So to take these values and do it, right? Well, as you see, this is also a very short and very effective way. So this should be adopted for a complicated function, correct? That's how it is. So we'll do one more transformation trigonometric function, and then you do it yourself using both the methods and see which one is good for you, correct? Thank you.